Kumai, Kandai, P-Rat, Kumai, Kandai.
Come with me to solve Triton puzzles in a house, where I'm also gonna be drinking my matcha.
Yeah.
And being a performative male.
Yeah, performative Triton soul. Oh my god.
Yes. This.
The J Den. Kumai, Kandai, P-Rat, Kumai, Kandai.
Come with me to solve Triton puzzles in a house, where I'm also gonna be drinking my matcha.
Yeah.
And being a performative male.
Yeah, performative Triton soul. Oh my god. Let's get this chat popped out so that can respond. The J Den talk. Alright. And then so yeah, if you want to watch the stream, pull up the stream. How the chat here? I've noticed the code has been small in the past video, so I'm gonna try and zoom in a little bit. Maybe like that. Maybe that'll help, right? I think that's it, right? Oh no, I need to post this link in a couple places. Jade. So like right here, I'm gonna post this in my story. I'm also gonna post this on a couple servers I'm in. All right, cool. So I feel like last time went pretty well, and so this time, the only thing I feel like went poorly last time was optimization versus implementation, right? So that's probably what I'm gonna focus on this time. But let's check out long softmax. So I need to calculate softmax of a batch of logics. Use one program block axis, block size B0 represents the batch of X of length N0. Block logic length T. Process it B1 less than T elements at a time. B0 represents the batch of X of length N0. What? Block logic length T. Process it B1 less than T elements at a time. Process it B1 less than T elements at a time. Block size B0 represents the batch of X of length N0. So I have X, so N0, block logic length T. So this is N0, and this is T. Process it B1 less than T elements at a time. Okay. And then, are B0 and N0 different? Yeah, I'm gonna say let's print N0 and B0. Let's see what comes out. 4 and 1. So I think I need to use a for loop again here. Oh no, I get it. I get it. We want to use each parallel thread to do a block in the row dimension, and then we're gonna loop sequentially through each B1 block in the column dimension. It's telling us we should use base 2 instead of base E. We also have this. Alright. So, thing to keep in mind is like we need to calculate maximum and subtract it. So we can get any numerical overflows. And we're gonna need to use an online softmax algorithm to not have to calculate the global. But maybe let's try that first, right? It sort of says something about 3 loops, so let's try with the 3 loops first. First thing is just gonna be, let's grab our logit and block, right? So let's grab our relevant block. We're gonna do, we have our PID already. We have log2e. What I want to grab here is, I want to say my I offsets equals tl.a range 0 to b0. In this case, I think it's a single row, right? But it could be multiple. And so we need to make sure that we jump ahead however many blocks, right? So times b0. That's our I offsets. And then instead of doing j offsets, we're going to say for block in tl.range 0 t, which is the length of our logits, right here. And then we're going to go increment by b1. And this is going to make us go through each chunk of columns. And so then for this, we could just calculate our j offsets as tl.a range 0 to b1. And here we can just add block. Last time I sort of made this mistake of calculating the ID so I could make it look more like this expression, but it ends up that this is equal to this product, so I can just skip that entirely. Now's the math, now's the harder part, right? First step is going to be finding the maximum of our column, right? So what I'll do is this, I'll say max equals like, I don't know if there's a place where they use like infinity here or something, right? I might ask ChatGPT this, right? In Triton, if I want to find maximum in a loop, do I use float minus inf to initialize or something else? Kind of looks like we could just use minus in. I'm gonna stick with minus in for now. We're gonna say minus float of inf like that, and then here I'll just say max equals the max of whatever my. Ooh no, we want a tensor of these, right? So I want to say, I want to use this right here. I want to say tl.full of, I don't know what this length should be, b0. Yeah, d type equals tl.float 32, like that. And so this max should just be like a and then here we'll say tl.maximum of, we'll load in our block, which should be x pointer So we'll say x block equals tl.load. How do we do our full offsets? We'll say ij offsets equals I offsets, and we want this to be a column vector. So like this, times t plus j offsets. What the what was that?
There's a fucking bug.
Yo, you tripping. It ain't that serious.
Yes, it is.
It ain't that serious. Wait. It ain't that serious. So we're gonna load this in. Say x pointer plus ij offsets. Or I should also make masks, right? So our I mask needs to be that I is the I offsets need to be less than n0, and the j offsets need to be less than t or n1. It's really not clear to me why n1 is here. I really think whoever made this is kind of messing up the notation a bit, but whatever. And then for our ij mask, we can say, for ij mask we can combine both of them, right? We could say I mask expanded just like this, and j mask expanded like this. And so I'm going to include that here. ij mask. Now I have my x block. I'm going to ask ChatGPT about this too. How would I update a whole how would I update a whole vector cumulative maximums? It's not clear to me. Yeah, I don't want to do the sequential loop. There has to be a better way. I'm saying I have a tensor, say with 4 rows, each with max so far for that row. How do I update them together as I encounter new elements? Yep. Yeah, so I would just say TL.maximum. Okay. So I'd say TL.maximum of this X block and the max. So let's print max, and then let's print max again and see how this goes. Whoa. What is happening? Okay, come back up. Ooh, this should be bigger. This should be B0. Wait a second. Yeah, but I want to collapse the block first. So you just do it twice. Okay. So I'd say TL.max of X block right here. And I do this across axis. I want to know the maximum. Would it be axis 1? I'm gonna try axis 0 first. And then put this. Let's try that. No, see, that looks wrong. Let's try 1. Yeah, I want this. So this makes sense. Now I have a tensor that gets the maximum each time. Is the vector so small that this is 4,200, right?
Wait, no, this goes twice, so then your cards.
Something seems wrong here. Oh, this. This needs to be like this. This is still wrong.
Wait, so we don't have our cards again? Oh, so then let's just switch.
Try this one more time. No. This is bad. I don't know what's going on. Oh, I know what's going on. I'm only printing at the end. Let's try this again. That looks right. That looks good. So we have our loop that finds the maximum for each row. Now we need to calculate this for each. Excuse me. We need to calculate this for each. For each row, right? So I need to find what's the sum of all the exponentials, right? So I'm gonna say my denominator equals TL dot zeros, like, no, TL dot zeros of B0, like this. And then we're going to keep it as flow 32. We're going to do a similar block right here. And what this block is going to be is it's going to be, instead of finding the max each time, we're going to say denominator plus equals TL dot exp of TL dot exp of X block minus max. And we want the sum of this. So TL dot sum of this is our denominator. And then let's print our denominator and see what we get. This looks kind of plausible. So now we have our denominator. Now we just need to calculate our numerator and write that into Z, right? So one more loop. And this time, when we load our X block, we're also gonna load our Z block, right? Actually, we don't even need to load it. We just need to store it, right? I'm gonna say tl.store z pointer plus ij offsets. And the same thing with the ij mask. And what are we going to store in here? We need to store our softmax expression, right? So here we found our max. We do our subtraction x, but then we do this division. So we just found this sum right here. Now we need to do this numerator. Basically, we're going to say softmax equals x tl dot x of x block minus max. Do you use division? Is that how it works? I think you can just do the division expression like this. Divided by denominator. Like that. And then I'm going to write this into our z pointer like this. And hopefully this just works. I don't know if I forgot something, right? But we'll give it a shot. Yeah, the result's correct. It's probably the fastest I've solved the puzzle for this. But we have a lot of optimization to do, right? We have 3 blocks here. You're doing a lot of repetitive sequential operations. And we're doing a lot of loads, right? I load the X block 3 separate times. We can combine some of these operations. Also, I'm using tl.exp, which can be expensive compared to exp2, using powers of 2, right? So that's going to be my first fix is let's, well, first I'm going to put this to GitHub, right? Let's try this on Max's GPU. Like this. And I'm gonna run it here. And ooh. I wonder what went wrong here. Did something go wrong? Oh. There's 2 functions here. I'm gonna put the brute force for both of them, right? For now. And just see if it passes. Oh, and yeah, that works. So I'm gonna say git add dot get status git commit dash m naive softmax. And now now that I've added these to my GitHub, let's optimize our code. First optimization, we're gonna get rid of this exp. And what we're gonna replace it with is this times base 2, right? So we have 2 log base 2 ex. So what I can do is I can use this constant right here and I can make this a exp2 and then multiply this like that. Same thing right here. I will multiply this right here and do an exp2. And now we don't have to do any weird like Taylor series stuff to calculate our exp2, and we should still have the same result. Yep, ta-da. So that was an easy fix. The other fixes are going to be harder. These ones we need to fuse some of our operations, right? We have 3 separate loops here where we're reading in the same data over and over. The question is whether we can take some of these, if we can do some of these at the same time in an online way, right? It actually ends up we can sort of leverage some of these exponent rules and stuff to update our values in a more clever way, right? So, how do we do this? We're gonna keep. Let's think about this a little bit longer. So what we're going to do is we're going to calculate this denominator sum as we find our maximum. You might ask, like, how can we do that? Because the calculator denominator, we need to know the maximum at each iteration, right? But what we're going to do is we're going to treat our maximum so far as if it's the true maximum, and then we're going to use exponent rules to compensate as we go, right? Basically, whenever I find my new maximum, I will use this right here to subtract out my old naive estimate and add in my new correct maximum. And once I make it to the end of the list, it'll be correct for all the values, right? Excuse me. So, to do this, first thing we're going to do is we're going to bring this up here, like this, and it got so loud. It's alright. This one went stupid well for like no reason. I mean, just not no reason, but like, let's keep going. All right, so let me get rid of this. Let me get rid of this. We're gonna get rid of all these. This is all the work that we're skipping. And instead of loading again, we're gonna do this right here, right? But one thing is, before we update this right here, right? Before we add this in, we're gonna calculate this, right? This is our, we're gonna extract this out. And how are we gonna compensate, right? So I have my old one so far. We're going to say denominator times equals what? We want to, what do we want to do? We want to do something like this, but for our maximums, right? We want to say take any old maximum value you had and subtract it, right? So maybe like this, right? Maybe I'll say old max equals max, max equals this, and the denominator times equals max minus old max. So what this should do, right, is to each, actually it should be old max minus max, right? Basically for each item in our sum, we are going to take the old max away and put the new max in. And I think this update is fine. I think this should just be correct. Hey, there we go. So look, right there, we replaced the exponent with base 2, and we fused these two operations into one. So now we're only doing one read on x right here, and then we're doing a read on x right here and a write to z. And now I'm not sure if these two can get fused, but I think no, right? Like I think if we think about this, I think the prompt kind of just said do to loop, right? There's one way to do this, 3 loops. That was a brute force we just did. You can also do it with 2 loops if you're clever. That's what we just did. Nice. So I'm gonna also add this to my GitHub. And let's put this over here. Like this. And let's try it out. See if it still runs. And we passed puzzle 8. So now I'm gonna say git add dot. And I could say I put fuse Softmax here. Nice. That solve was great. I might update the title. I might do another one. I don't know. That's too ambitious. Simple flash attention. Can I do flash attention in an hour? I don't know about that one. We'll resume later. We'll leave it at that. You know what? I'm happy about that. We did Softmax. We did it quickly and correctly, and we optimized it. Yeah. Let's leave it at that. Let's leave it at that.